Okay, the next thing we're having a look at here is a sine function or circular functions or whatever you want to call them. I don't care. Actually, no. We're looking at the sine function, which is a type of circular function. Alright, so it looks like this. So if we just do y equals sine of x, it looks like this. It's going to start here at 0 and 0, and then it's going to go up, come back down, and then go here as well. Now, there are some key points to this graph. We have what we call a period, which is how long it takes for it to repeat itself. So that starts here at 0, goes up, down, and goes back here to 0. So it's the same thing. So it's going up, and here is going up. So the distance between here and here is 6.28. It's 2 pi. We do that by, we'll have a look at the maths for that in a second. Then the other thing we have is an amplitude. An amplitude is how far your graph goes from the x-axis to its maximum or from the x-axis to its minimum. As we can see here, the amplitude is 1. So it goes up 1, it goes down 1. We're not interested in the sign, it's just the distance, it's just the absolute value, so it's just 1. Okay, and then so from there, let's have a look at the general equation. So our general equation to a sine graph is a times sine n times x plus k. Now you could probably already work out what some of these things do. A controls the amplitude. Okay, so that controls the amplitude. So whatever the value for A is, that is our amplitude. N controls our period. So it's 2 pi for this because your period, which our symbol is T, equals 2 pi over N. So we'll have a look at that change in a minute. This K, as you know, just like with a parabola, with a square root function, with anything, shifts your equation up or down. Positive K moves it up, negative K makes it move down. Let's have a look at some of these things in action. So let's say we've got 2 sine of x. Here we go. Sent up to 2, down to negative 2, and then still got the same value here. So this has an amplitude of 2. Positive 2, negative 2, but it's still 2. Let's change, instead of the 2 here, let's put the 2 here and let's see what it does. Well, it's squashed our graph. So we go up, down, and back up. So we've got a cycle here at pi, and we've got another one here at 2 pi. So in terms of this, the period for this red graph here is 2 times pi divided by n. Well, n is 2, so 2 times pi divided by 2 is just pi. So if we have a look at this, let's go minimum, analyze graph, we're looking for where it's 0, going for the red one, between here and here, 3.14, well it happens at pi. So that's what's happening for that one there. Now let's change this, bring it back to x, and we will say this, make this -1. Well, it pushes our graph down. Now, what's ended up happening here is that we've still got an amplitude of 1. That's because I gave you an incorrect definition before. For this one I said it's how far away it is from the x-axis. That's a coincidence. It's not how far away it is from the x-axis, the maximum and the minimum. It's actually how far away it is from the midpoint, how far the maximum is from the midpoint and how far the minimum is from the midpoint. The midpoint here is 0. That's the average value or the midpoint. So for here, the average value is -1. Which we find by -1. So the amplitude for go from -1 to 0 is 1, and to go from -1 down to 2 is also 1. So our amplitude is still 1. Coefficient here would be 1. What it's done is that it's dropped down the graph by 1. So the other thing that it's affected is the range. It's affected the range. So in this original sine f of x, the range is -1 to +1. Here it is -2 to 0. Okay, let's have a look at some code. Let's have a look at what we can do here. So this is what I'd like to see. So we're going to run this thing. I think it's called sinefunc. Sine_func. Yep. It asks for an a value. So that's your coefficient. So I'm just going to set that to 2. It asks for an n value. That's your coefficient. So that controls the period. So I'm going to set that to 1. And it asks for k, and I'm going to set that to 0. So it tells us we have got, that's our function, 2 sine of x. We've got an amplitude of 2, got a period of 2 pi, and we've got a range of 2 to -2. So let's try and change this up a little bit. Let's run it again. Sine, and we'll say make this -3, because we could have a coefficient of -3. Let's make this n of 1 over 2. And so the k value plus 1. So for this is what it looks. This is what it looks like. We've got a negative value. So this is the way Kaz just does it. So 1 minus 3 sine of x on 2. Amplitude is 3. That's that. Notice it's not -3. It is an amplitude of 3. We've got a period of 4 pi. So this is the same as saying x a half times x. So 2 over a half is 4. And our range goes from -2 to 4. Let's check that out. We are going to graph this thing here. So I'm going to make a new thing. So it's 1 graph 1 minus 3 sine of x on 2. And it looks like that. Let's check our analyze graph. We'll go for minimum from here to here. Happens at -2. Minimum, analyze graph, maximum here to here. So -2 to 4. Let's have a look at that. -2 to 4. There's our range. Period 4 pi. Let's have a look at that. So for it to repeat itself, we've got a starts off here. 4 pi is going to be about 12. So it looks like it's happening at about there, which looks about right. We can check that. Let's graph it at 1. And we'll say menu, analyze, intersection from here to here, and it's happening at 12.6. That's about 4 pi. Whoops. So that is what we're seeing happening there. So that's what I'd like to see happen. So I'd like you to do that both with sine and cos. So just to go through that again, let's see it in action. Sin func. We've got an amplitude of say 5, an n value of say 2 pi, and a k value of -1. So an amplitude of 5 because of that. Period of 1, 2 pi over 2 pi is 1, and a range of 4 to 6. So if you've worked it out, hopefully you've worked it out how you go about calculating this range. Now, what you may have issues with is this amplitude. Like I said, it's an absolute value. So if we have a look up a little bit, here where it was where the a value was -3, it still gave us a positive answer. For that, what you need to use is your absolute value. So if you say abs -3, it just gives you 3. Say abs of 3 gives you 3, but if you do abs of -59, it just gives you 59. You've got to take advantage of that function. So that's the next task to work on. I would like for you to do this with sine and also with cos. And with cos, all you're doing is you're just changing cos. Changing sine to cos. So ask for a, ask for n, ask for k, put out the function, write the amplitude, write the period, write the range. And the range has to be smallest to highest. Here this is incorrect. Highest to smallest, it's got to be smallest to highest. I'll let you guys have a think about that because you guys are good at maths.